In this lesson, let us see an example of three planes makes infinitely many solution, and let's see how to find that solution. Okay, the question is, show that the three planes given below makes infinitely many solution, and you have to find the solution of it. The plane equations are, the first plane is 2x minus 4y minus 3z equal to 4. Pi 2 is minus x plus 3y plus 5z equal to minus 2. And the third plane equation is 3x minus 5y minus z equal to 6. Okay, first let us make the coefficient matrix. Okay, as I said in my previous videos, instead of starting with 2, here I have one equation having the coefficient of 1 or negative 1. So first I'll use the first row with the second equation. So the coefficients of second equation are 1, 3, 5, and minus 2. And I write the first equation as a second row, which is 2 minus 4 minus 3 and 4. The third row coefficients are 3 minus 5 minus 1. This is z, so which is having a coefficient of 1, minus 1 and 6. Okay, as you know, our aim is to make this term, and this term zeros. Okay, write the first row as it is, 1, 3, 5 and minus 2. Here the second row first term is 2, and here first row first term is, sorry, it should be negative 1. This is minus x, so this coefficient is negative 1, 3, 5, negative 2. The coefficients are here 2, negative 4, negative 3, 4, 3, minus 5, minus 1, 6. Okay, we need to cross check before we start, otherwise even if with one number wrong, the whole question goes wrong. All right, so this term is minus 1. So what we can do, R2 is, we have 2. So multiply the first row by 2 and just add. So the relation is new R2 is R2 plus 2 times of R1. Since already there is a negative sign, you should not subtract, you can add to make it as 0. So 2 minus 2, we make it as 0. Here, coming to the second term, R2, which is minus 4, plus 2 times of the corresponding term is 3. Minus 4 plus 6 will make it as 2. So that comes over here. Next, coming to the next term, R2 is minus 3 plus 2 times of the corresponding term is 5. Minus 3 plus 10 would be 7. So this term is 7. Coming to the last term, 4 plus 2 times of minus 2. 4 minus 4 makes it as 0. So we're done with the first row. Sorry, second row. Okay, see the third row. Third row first term is 3, and here we have negative 1. So new R3, the new row 3 is R3 plus 3 times of R1. Fine. Okay, here if we do 3 minus 3, we makes it as 0, the first term. Coming to the second term, minus 5 plus 3 times of the corresponding term is 3. Minus 5 plus 9 is positive 4. Next, minus 1 plus R3 plus 3 times of R1. Corresponding term of minus 1 is 5. Minus 3 plus 15 is 14. The last term, 6 plus 3 times of minus 2. That gives you 0, right? Okay, now just observe the second and third row. Now we made this zeros, right? And our aim is to make this a 0. But here you can see this is multiples of 2. If we divide by 2, I get the second row easily. Okay, so next step, write the first and second rows as it is: 1, 3, 5, minus 2, and 0, 2, 7, 0. What you can do, new R3 is R3 divided by 2. If you divide by 2, you get 0, 2, 7, and 0. Right? Now our aim is to make this is 0. This term is 0. Okay. What you can do, as I already said, to make this third row second term 0, you should not use the first row. That makes the third row first term non-zero number. You have to use second and third row to make this term 0. Fine. We'll write the first and second rows as it is: minus 1, 3, 5, minus 2, 0, 2, 7, 0. Now R3, new R3 is R3 minus R2. If you do R3 minus R2, this becomes 0. 2 minus 2 becomes 0. We are trying to make this term 0. We made it. Okay, in that process, the next term also getting 0. 7 minus 7 is 0. 0 minus 0 also 0. Right? You seen in the first video, I explained this H. This is the H position and this is the J position. Right? Both are getting 0, which is 0x plus 0y plus 0z equal to 0, which means one equation out of 3 simultaneous equation, one equation is completely got eliminated. Okay, so this indicates that the 3 simultaneous equation will make infinitely many solutions. So this is the category of infinitely many solutions. If two lines intersect, then you can say it's a unique solution. Okay, because it is touching at one point. Okay, if two lines are lying on each other, then it is touching at many points. So that is infinitely many solution category. So here, when we are getting infinitely many solution, basically our solution will be in the form of straight line only. Okay, how to do that? You take the general solution for z is t, is an arbitrary constant. T belongs to any real number. Okay, let us assume z equal to t. You can plug in t values 1, 2, 3 for any number. T belongs to real numbers, right? If we choose t is 2, then accordingly the x and y values takes. Okay, so that would be that is one of the solution when you take t is equal to, like that many solutions you can take. All those solutions will be lying on the line of contact of these 3 planes. Fine. So z is t, we take from the last row since it got eliminated. Going back to the second row, we have 0x plus 2y plus 7z equal to 0. In this, you plug in the t value is, z value is t, we get 2y plus 7 times t equal to 0. And this gives 2y equal to minus 7t and y is equal to minus 7 by 2t. Okay, this is these solutions are looking in the parametric form of straight line. So if you want, you can write it as y is equal to 0 minus 7 by 2 times of t. Okay, we'll come back to this later. We got z in terms of t and y in terms of t also we got. Next, we need to get x. That we can obtain from the first row. The first row equation is minus 1x plus 3y plus 5z equal to minus 2. Okay, so the equation is minus x plus 3y plus 5z equal to, it's minus 2. Right here we have the values of z is t and y is minus 7 by 2t. Plug in these two values, you will get the relation of x in terms of t. 3 times of minus 7 by 2t plus 5 times of t equal to minus 2. So you get minus x minus 21 by 2t plus 5t equal to minus 2. If you simplify these two t's, we'll get minus x. If you take LCM of 2, we get minus 21 plus 10. We'll make it as minus 11 by 2t equal to minus 2. Fine. Now we need to get x. So I send this x to the other side and this to the left side. We get x equal to 2 minus 11 by 2t. Fine. So what are the values we got? X is 2 minus 11 by 2. We can write it as 5.5t. And y, we got it as, since there is no constant here, I'll write 0 minus 3.5t. Right? 0 minus 3.5t. 7 divided by 2, I have written it as 3.5 in decimal. And z equal to t, 1t. Okay, so you can write z equal to 1t. So this is what that infinitely many solutions.
So this is that infinitely many solution. This also you can write it as this xyz, you can make it as r vector, and this 201 is the point component plus t times of the direction components are minus 5.5, minus 3.5 and 1. You know that this is the vector equation of a straight line, which is in the form of r vector equal to a vector plus t times of b vector, where a is the point on a line and b vector is the direction along the straight line. Okay, this is how we can find the infinitely many solutions in the case of three planes, making three planes makes. Thanks for watching.